Math book, pencil, and eraser. You don't really need these foam shapes today. If you want to get them, you probably could use them, but you don't have to. So today we're starting with 12.2, describe two-dimensional shapes. So we talked about this some with 3D shapes, didn't we? That they had curved sides and flat sides. So now with two-dimensional shapes, we're talking about curved sides and straight sides instead of flat. So use two-dimensional shapes. I spent a long time trying to figure out if there was a certain set of shapes you were supposed to have. And if there were, I can't get them. So we're going to be, instead of actually having a bunch of shapes that we sort and use, we're going to be doing a lot of imagining and visualizing. So it's much better if you can do it with your hands first, but we don't have that option. So we're going to really work our brains on this. I'm glad you were able to use your hands with our 3D shapes some. I'm glad you have your pattern blocks for some of these, but they are not going to be helpful with curved shapes, are they? Because none of these have curved sides. Now, if you want to use some of them for straight sides, you may, but I don't want you to trace them. You can do your best to draw them, but don't trace them. Does that difference make sense? So a shape with curved sides, well, the first most obvious one, right, is a circle. If you can think of some other shapes with curved sides, go ahead and put them here. And then here, just draw some shapes with straight sides. Draw at least 3 shapes with straight sides over there. All right, guys. Now, here we're going to talk, first of all, the word trapezoid. We've used this word some, and hexagon. You can see a trapezoid kind of looks like a rectangle that has the sides squished in a little bit. But do you see how this line and this line are still parallel to each other, right? These still keep going straight this way and straight this way. You don't see these lines, they squish in on each other. These lines don't squish in anywhere. Opposite ones in a trapezoid still are even to each other. They don't squish in on each other. All right. We talked about the word vertex or vertices a couple of days ago, right? So that's not a new one. Here where the two sides come together and point out, that's a vertex. And then there are sides. So you're going to need blue and you're going to need red. And we're going to trace each straight side. Jump, 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 jump. Jump, 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 jump. And you're going to be circling each vertex. 1, 2, 3, 4 on a trapezoid, and 1, 2, 3, 4, 5, 6 on a hexagon. Now down here, again, you can see you're not going to be tracing these because your hexagon is too big for that spot, but you are going to draw it. Now the hexagon is the trickiest one, and they did give you one to trace. So you can trace that one, and then you write here the number of straight sides. Well, we just counted that, right? 6, and the number of vertices, 6. So boys and girls, you can do these: rectangle, square, trapezoid, triangle. Now trapezoid, I'll help you draw one. Let's do top and bottom lines that are the same length. That are the even to each other. They don't squish in on each other, but they're not the same length. And then you can draw the other sides that squish in. So this, you guys can finish how many straight sides, how many vertices on each of them. Next page. Here again, you're going to use your red and blue. Trace each straight side with the blue. 1, 2, 3, 4. And write how many sides. Circle each vertex with the red. And then write how many vertices. Do that for each of these. Now, boys and girls, I'm not going to give you the answers on these, but I bet if you have paid attention to what you've done up here, I'm a shape with 3 straight sides and 3 vertices. I bet you could draw that. I am a shape with 4 straight sides that are the same length and 4 vertices. Boys and girls, I bet you can figure those out. Last page. Jake draws a shape that has fewer than 5 sides. It has 3 vertices. Now, boys and girls, I really think that you noticed here on this other page that shapes have the same number of sides and vertices. I hope you noticed that. So if his shape has 3 vertices, it must have 3 sides, right? Is 3 also fewer than 5? It is. So you can go ahead and do that here. Now, boys and girls, every few years I get a student who's really, really smart with math. And every few years, that student who's really, really smart with math wants to check and make sure you cannot make a shape that has different number of sides and vertices. If you want to try that, you go right ahead. And if you can make a shape that has a different number of sides from vertices, has more vertices than sides or more sides than vertices, I want to see a picture of it because I don't think anybody's ever done that before. Give it a try and see if you can if you want to. I've never had anybody do it other than my very, very smartest students, or I've never had anybody try other than my very, very smartest students, and none of them have ever been able to do it. You are welcome to try if you would like to. My smartest ones usually do want to give it a try, if for no other reason than to check and see if that's really true. Meg draws a shape with 4 sides. She labels it as a trapezoid. Well, boys and girls, you can do that, can't you? You can draw a shape with 4 sides that could be labeled as a trapezoid. All right. Ben draws 2 different shapes. They each have only 4 vertices. Now, boys and girls, if you need to, you can flip back here to this side. What 2 shapes both have 4 vertices, but they're different shapes? They're really similar, but not exactly the same. All right, test prep. How many vertices does a hexagon have? I think by now this should be a pretty easy one for you to answer. Okay, boys and girls, this shape stuff, especially Thursday, but a little bit today too, might seem like just really simple. I want you to be sure you're really taking your time to let your brain sink down into these shapes, because later in the next couple of weeks, when we don't have the shapes to actually be moving with our hands, your brain is going to really need to know these shapes so that you can imagine in your mind cutting some of the shapes or taking a shape and flipping it around and sticking it on another shape. And your brain can't do that unless it's really, really familiar with the shapes. So definitely don't just rush through this and go, okay, I'm just going to get it. Make sure you really understand what you're doing. Otherwise, when we come to those harder ones and you won't have the stuff to use with them, you just have to imagine it in your mind. Your brain's going to go, I don't know this enough. So take the time now to really, really know it. And then when we get to those ones where you don't have the shapes, you just have to imagine it. Your brain is going to be able to do it.